Good morning, students. In the last lecture, we have discussed how to obtain the directions cosines of given line if the direction of line is given. Okay. Now we are going to discuss the next topic: direction cosines of line passing through 2 points, okay. If the line is passing through two different points, then how can we calculate the directions cosines of that line? Suppose this is our line L. The line is passing through the point A, x1, y1, z1 and point B, x2, y2, z2. Suppose the line L is passing through the point A, x1, y1, z1 and second point B, x2, y2, z2. Then we can calculate the directions cosines by use of the vector in the direction of line L, by use of the vector in the direction of line L, which gives the direction of line. The vector, this vector AB, which gives the direction of line. Here direction of line L bar equals to vector AB. फर्स्ट ऑफ ऑल हमको वेक्टर ए बी निकालना पड़ेगा, क्यों? क्योंकि हमको डायरेक्शन ऑफ लाइन एल चाहिए. अगर डायरेक्शन ऑफ एनी लाइन we will calculate the direction of any line by use of the direction vector of that line. तो हमको पहले वो लाइन का डायरेक्शन वेक्टर निकालना पड़ेगा. तो ये लाइन की डायरेक्शन में वेक्टर है वेक्टर ए बी. ये लाइन है तो उसकी डायरेक्शन में ए बी वेक्टर उसकी डायरेक्शन रिप्रेजेंट करेगा. तो डायरेक्शन ऑफ लाइन एल बार इज इक्वल्स टू वेक्टर ए बी एंड वेक्टर ए बी इज गिवन एज x2 minus x1, y2 minus y1 and z2 minus z2. Now we know that the directions cosines cos alpha, which is equals to x2 minus x1 divided by magnitude of vector AB. Here AB vector, or we can also write magnitude of L bar. Okay, same way cos beta, which is equals to y2 minus y1 divided by magnitude of vector AB, and cos gamma is given by z2 minus z1 upon magnitude of vector AB. These are the directions cosines of line passing through two different points, A, x1, y1, z1 and B, x2, y2, z2. Okay, here AB vector is the direction of line. हमको पहले डायरेक्शन ऑफ लाइन निकालना पड़ेगा और उसका यूज करके हम L बार मिल गया आपको. L बार इक्वल्स टू L1, L2, L3. दिस इज इक्वल्स टू L1 अपॉन मैग्नीट्यूड ऑफ L बार, L2 upon magnitude of L bar and last one L3 upon magnitude of L bar. ये वही चीज है पर हमको ये L1, L2, L3 पहले निकालना पड़ता है. नेक्स्ट हम उसके रिलेटेड एक क्वेश्चन देख लेते हैं. एग्जांपल नंबर 3 is given here. Find the directions cosines of the line passing through the 2 points. The first point is A minus 2, 4, minus 5 and the point B is given 1, 2, 3. Okay, first of all we have to obtain the direction of line L bar. First of all I am obtaining the direction of line L bar, which is equals to vector AB. डायरेक्शन ऑफ लाइन L बार which is equals to वेक्टर AB। सपोज ये पॉइंट ये है, ये पॉइंट B है, तो हमको उसमें से पास होती लाइन एक ये मिलेगी और उसकी डायरेक्शन हम AB वेक्टर भी ले सकते हैं और BA वेक्टर भी ले सकते हैं। तो हम कोई भी एक वेक्टर को हम डायरेक्शन ऑफ लाइन ले लेंगे, तो L बार इज इक्वल्स टू वेक्टर AB और वी कैन आल्सो टेक वेक्टर BA। તમે કોઈ भी એક લઈ શકો છો। So L bar is equals to vector AB. Now what is vector AB? So vector AB means B minus A. So B minus A that means 1 minus minus 2, which will become L bar equals to 1 plus 2 3, 2 minus 4 minus 2, 3 plus 5 8 here. So this is your L bar. This is your L bar. Okay, now the direction cosines of line is given by cos alpha equals to L1 upon magnitude of vector L, cos beta which is equals to L2 upon magnitude of vector L, and cos gamma which is equals to L3 upon magnitude of vector L. What is L1? Here L1 is 3. Divide by magnitude of vector L. Magnitude of vector L means under root 9 plus minus 2 square 4 plus 8 square 64, same as cos beta which is equals to minus 2. L2 means minus 2. Divide by magnitude. The magnitude under root of 9 plus 4 plus 64, and cos gamma which is equals to L3. Here L3 is 8. Divide by under root 9 plus 4 plus 64. cos alpha की वैल्यू मिल जाएगी 3 upon 64 plus 4 68 plus 9 77। therefore direction cosines are 3 by root 77, second हो गया minus 2 by root 77, and the last one 8 by root 77. These are the directions cosines of our given line. Passing through the 2 points. First of all हमको उस लाइन की डायरेक्शन निकालनी पड़ेगी। अगर डायरेक्शन है L बार तो हम उसके डायरेक्शन cosines इजीली कैलकुलेट कर सकते हैं। cos alpha equals to L1 by magnitude of L bar, and cos beta equals to L2 by magnitude of L bar, and cos gamma equals to L3 by magnitude of L bar. Now we are going to discuss next question, exercise 11.1, question number 5. Find the direction cosines of the sides of the triangle whose vertices are 3, 5, minus 4, minus 1, 1, 2, and minus 5, minus 5, minus 2. Okay? हमको ये ट्राइंगल की 3 वर्टाइसेस गिवन है। So suppose this is our triangle ABC. This point is A, 3, 5, minus 2. Suppose this point is B, minus 1, 1, 2, and the point C is minus 5, minus 5, minus 2. Okay? Find the directions cosines of the sides of triangle. So sides of triangle are AB, BC, and CA or AC. Okay, तो first of all हमको directions cosine निकालनी है vector AB की. Okay, तो first of all we need the vector AB here. Find the vector AB first. What is vector AB? तो vector AB. Vector AB which is equals to, चलो B minus A, minus 1, minus 3, minus 4, 1 minus 5, minus 4, and 2 plus 4, 6. This is vector AB. सेम वे BC वेक्टर की भी हमको डायरेक्शंस कोसाइन निकालनी है, तो वेक्टर BC भी फाइंड आउट कर देते हैं। चलो वेक्टर BC which is equals to वेक्टर BC C minus B, we are getting -5 plus 1 -4 -5 plus -1 -6 and -2 -4, same as वेक्टर AC और वेक्टर CA। तो CA वेक्टर की भी डायरेक्शंस निकालनी है, तो वेक्टर CA which is equals to CA और AC તમે કોઈ બી લઈ શકો છો, ડાયરેક્શન લાઈનની કોઈ બી હોઈ શકે છે, both the direction of line will be applicable, કોઈ બી લઈ શકો છો, okay? Therefore vector CA which is equals to A minus C 3 plus 5 8 5 plus 5 10 and -4 plus 2 -2. Vector AB, vector BC and vector CA are ready. Now the direction cosines of vector AB or directions AB which is given as cos alpha equals to, चलो वेक्टर AB x coordinate -4 divided by magnitude of AB which is given as under root of -4 square 16 plus -4 square 16 plus 6 square 36, same as cos beta which is equals to -4 upon under root 16 plus 36 and cos gamma which is equals to 6 upon under root 16 plus 36. Now we can calculate it. 36 plus 16 plus 16, 6 plus 6 plus 6 18, 1 carry, 3 plus 1 plus 68 is there. Therefore we can write cos alpha equals to -4 divided by root 68, cos beta which is equals to -4 divided by root 68 and cos gamma which is equals to 6 by root 68. Therefore the directions, so you have to write the statement here, the directions cosines of vector AB are -4 by root 68, -4 by root 68 and 6 by root 68. Therefore the direction cosines of AB are -4 upon root 68, -4 upon root 68 and 6 upon root 68. अगर ये सिंप्लीफिकेशन होता है तो करने का, अदरवाइज नहीं करोगे तो चलो. Next we are going to discuss now the direction cosines of vector BC which is given as cos alpha which is equals to -4 divided by under root -4 square 16 -6 square plus 36 and plus -4 square plus 16, same as cos beta which is equals to -6 by this is equals to root 68 direct લખું છું. Next cos gamma which is equals to -4 upon root 68. Okay, therefore the direction cosines of BC are, answer will be -4 upon root 68, -6 upon root 68 and -4 divided by root 68. Clear? Next, now the direction cosines of of vector CA or vector AC. Okay, the directions cosines of vector CA. Here vector CA is here. Therefore, we can calculate it. Cos alpha equals to 8 by under root of 8 square 64 plus 10 square 100 plus minus 2 square 4 cos beta which is equals to 10 upon under root 64 plus 100 plus 4 and cos gamma which is equals to minus 2 divided by under root 100 plus 64 plus 4 168 directly. Clear? Therefore, the direction cosines of vector CA, the direction cosine of vector CA are given as 8 by under root 168, 10 by under root 168 and minus 2 by under root 168. Clear? Write down this. Now we are going to discuss next question, last question of this exercise, exercise 11.1, question number 4. Same type of question, example 5 is there. Show that the points 2, 3, 4, minus 1, minus 2, 1 and 5, 8, 7 are collinear. There are many methods to represent or to prove that or show that these 3 points are collinear. We can calculate by use of distance, any two distance, summation of any two distance equals to third distance. એ લોજિક से આપણે ચેપ્ટર 10 માં કરી ગયા છે. બટ હવે થોડાક એડવાન્સ થઈને જો કોલિનિયરિટી ની બીજી એક ડેફિનેશન છે એનો બી યુઝ કરીને આપણે પ્રૂવ કરી શકીએ. સપોઝ this is the line. Point A is 2, 3, 4. Point B is minus 1, minus 2, 1 and point C is 5, 8, 7. Okay, these 3 points are collinear if vector AB and vector AC are collinear. If vector AB and vector AC are collinear, then we can say that these 3 points are collinear. ओके, तो हम ये प्रूव कर सकते हैं कि AB वेक्टर और AC वेक्टर अगर कोलिनियर है तो ये तीनों पॉइंट कोलिनियर है. फर्स्ट ऑफ ऑल हमको ए वेक्टर AB फाइंड आउट करना पड़ेगा. चलो, व्हाट इज वेक्टर AB? वेक्टर AB will becomes -1 -2 -3 -2 -3 -5 and 1 -4 -3. And vector AC, calculate the vector AC. 5 - 2 3, 8 - 3 5 and 7 - 4 3. So here vector AB equals to lambda times vector AC. If we take vector AB equals to lambda times vector AC, because we have to prove that AB and AC are collinear vectors. If lambda exists, lambda be any scalar exists like this, AB vector equals to lambda times AC, then we can say that AB and AC are collinear vectors. Otherwise we can't say that. Chalo, vector AB is given -3 -5 -3, which is equals to lambda into 3 5 3. Now multiply this, we are getting -3 -5 -3, which is equals to 3 lambda 5 lambda and 3 lambda. Compare the respective elements. We are getting -3 equals to 3 lambda, -5 equals to 5 lambda and -3 equals to 3 lambda. Therefore I am getting lambda equals to -1 from this, lambda equals to -1 from this, lambda equals to -1 from this. Therefore we can say that AB equals to -1 into vector AC. Therefore AB vector and AC vector are collinear vectors. If they are collinear, then we can directly say that A, B and C points are also collinear. Okay, જો lambda ની value same ના આવે તો they are not collinear, then we can't say that they are collinear. Okay, but if the lambda equals to same for each and every case, ત્રણેય કેસ માટે lambda -1 છે, therefore we can say that A, B, C are collinear points. Now the next topic, theoretical topic, the equation of line. The equation of line, this is most important topic. હવે આ ચેપ્ટર ની મેઇન સ્ટાર્ટિંગ થયું. અત્યાર સુધી જે શીખ્યા એ બધું 10th ચેપ્ટર ને રિલેટેડ રિવિઝન પોઈન્ટ ઓફ વ્યૂ. ઓકે, the equation of line. We know that the equation of line having many forms. Standard 11, straight lines, the equations of line, Cartesian form, the equation of line passing through the 2 points, the equation of line having slope m and passing through some point. Okay, આવા ઘણા બધા ફોર્મ હતા, p alpha form. Okay, આવા ઘણા બધા ફોર્મ્સ તમે લાઇન્સ ને રિલેટેડ સ્ટડી કર્યા છે સ્ટાન્ડર્ડ 11th માં. એવા જ ફોર્મ અહીં આપણે વેક્ટર્સ ના ફોર્મમાં કેલ્ક્યુલેટ કરીશું. તો લાઇન ઇન અ સ્પેસ આપણે અત્યારે હાલ જે વાત કરી રહ્યા છે the equation of line in a space, સ્પેસ ની અંદર જે લાઇન હશે એની વાત કરવાની છે. સ્પેસ ની અંદર મીન્સ 3-dimensional geometry line can be like this. Okay, now I am going to discuss the first vector equation of line passing through the point A bar, and the direction of line is given by L bar. Okay, the vector equation of line passing through the point A bar. Okay, the position vector of point A is given here A bar. A bar is the position vector of point A with respect to origin, and the direction of line L bar, okay, is given by R bar equals to A bar plus lambda L bar, where lambda be any scalar means lambda belongs to R. This is the vector equation of line passing through the point A bar, and the direction of line L bar is given by R bar equals to A bar plus lambda L bar, where lambda belongs to R. चलो જોઈએ પ્રૂવ કરીએ આપણે. See here, this is your Cartesian coordinate system in 3-dimensional. This is your x-axis, this is your y-axis, and this is your z-axis. Suppose the line L is like this. This is your line L. This line is passing through the point. A bar. Therefore, the position vector of point A with respect to origin is your A bar or a vector A. Okay. Now, I am taking one variable point on the line which is given by the point P having position vector R bar, this is the point having position vector R bar. Okay, Now see here. Here P point is variable point, here R bar is variable vector, variable position vector. That means P point represents all the points of line L in general form. In general form. Okay, so R bar is your variable point on the line. Clear? Now see here. Vector AP. Vector AP. The vector AP is like this. This is your vector AP. And the direction of line is also given. The direction of line is also given. The direction of line is L bar. See here, the direction of line is also like this, L bar, and the vector AP is also like this. The vector AP and the direction of line both are collinear vectors. The vector AP and the L bar may be on this side or on this side, but we can say that they are collinear. भले same direction में होए कि opposite direction में होए, but we can say that they are collinear. Therefore, vector AP and vector L bar are collinear vectors here. Clear? Okay. Therefore, we can write AP vector and direction of line L bar are collinear vectors. Therefore, we can write vector AP which is equals to lambda times L bar, where lambda be any scalar means lambda belongs to R. We can write like this: if two vectors are collinear, then vector AP is equals to lambda times L bar. Lambda belongs to any scalar, lambda belongs to R. Now, what is vector AP? So we know that the vector AP is given as R bar minus A bar. R bar minus A bar, which is equals to lambda L bar, where lambda belongs to R. If we make the subject R bar, then we are getting R bar equals to A bar plus lambda L bar. Lambda belongs to R. This is the vector form, the vector equation of line. Okay, passing through the point A bar and the direction of line is L bar. Clear? आने related questions केवा पूछा है तो जो ये questions. Okay, find the equation of line. Find the equation of line passing through the point, passing through 1, 2, 3, and the direction of line, is 2, 5, 8. So first of all, here it is given that the line is passing through the point which is A bar, which is equals to 1, 2, 3, and the direction of line, which is denoted as L bar, is given here 2, 5, 8. In vector form, આપણે vector form માં લઈશું. In vector form, લખ્યું છે. In vector form. Okay, so the equation of line in vector form is given by R bar equals to A bar plus lambda L bar, where lambda belongs to R. First of all, we have to put the values of given vectors. Vector A bar is 1, 2, 3 plus lambda L bar 2, 5 and 8. Okay, this is the vector equation of line passing through the point 1, 2, 3 and the having direction 2, 5, 8. ध्यान रखજો કે r1 ની વેલ્યુ કશું પુટ કરવાની જરૂર નથી, આનું સિમ્પ્લિફિકેશન બી કરવાની જરૂર નથી. આ તમારો ફાઇનલ આન્સર જ છે. તો this is the vector form of equation of line. Well, lambda belongs to R, તમારે દરેક જગ્યાએ કન્ડિશન મેન્શન કરવાની. ઓકે, lambda belongs to R, કન્ડિશન મેન્શન કરવાની. કે તો આ થઈ ગયું તમારું વેક્ટર ઇક્વેશન ઓર વેક્ટર ફોર્મ ઓફ ધ લાઇન ઇન સ્પેસ. ઓકે, નેક્સ્ટ ટોપિક આપણે નેક્સ્ટ ડે જોઈશું. થેન્ક યુ વેરી મચ.